Hi guys, BuildZoid here, and today we're going to be doing a video I really don't like doing, but I think is necessary. So hopefully I get it all in one take. We're going to be going through a couple different memory configurations and how they overclock with the MSI Z490 Unify. And the point of these different memory configurations is that we're going to be looking at dual rank and single rank setups with the exact same timings and exact same voltages. And we're going to look at the performance and how they can overclock. So, the first setup we're going to be doing is two Patriot Viper Steel memory sticks, right? You can see them in there right now. Each stick is 8 gigs. They use Samsung B-Die memory ICs, so they are single rank memory sticks. And we have one memory stick in each channel, so we have one rank on each memory channel. So then, here's the settings. We're on a 10900K at 5 gigahertz with the hyperthreading disabled because the cooling system is suboptimal in this setup right now. So as much as I wish we could run like faster or with all the hyperthreading enabled, it would overheat if I did that. Anyway, right now the memory is just running at 4400. It's not XMP because one of the memory kits that I've decided to mix into this test for... Because the thing is, like, a lot of people will, well, I've intentionally made this more annoying for myself, but these right here are 16 gig single rank memory sticks. And I figured it would be important to include them, partly because we have, partly to show that, one, 16 gig single rank sticks exist, two, to address all the idiots in the comments who are going to be like, oh, but 32 gigs is faster than 16 gigs, when it's like, it depends. So that's what that kit is for, to show that it depends. Anyway, so here's the settings that we're going to be running all of these kits all the time. So they're kind of loose for some of these sticks, and they're actually well, no, they're just generally pretty loose settings because I want this to work. So we've got 18, 22, 22, 44, 700. I've tightened up some of the sub timings because the board has a this is a Z490 Unify. The board does its best for like making your life easier if you're a beginner. Side effect of that is also it likes to load up some pretty awful auto settings in terms of performance. Also, it really likes to like not follow... Wait, right now we're at 2133. Okay, so it's fine. Yeah, the board auto detects if you change memory kits. So, we're going to do a performance test at 4400 first, because I don't know where this is going to top out. And then we're going to overclock the, we're going to push the DIMMs to even higher frequencies. And I'm using 1.45 volt system agent voltage here, mostly so that we get an extended memory frequency range. At the same time, we're on a 4-DIMM motherboard, which is kind of suboptimal for that, but capture card's being very cooperative today again. It's the NVIDIA GPUs, I tell you. Like, for whatever, like, with AMD GPUs, it's not as bad as it is with NVIDIA cards. I have no idea why. Anyway, so yeah, my benchmark of choice for today is LinPack, which is why we can't have hyperthreading, because if we had hyperthreading, LinPack would absolutely melt the system. So we're just going to run the 6 gig workload. We're just going to do 2 passes. And yes, yes, no, because 6 gig workload doesn't take that long, and the 2 passes is just to give us some kind of average. Ideally, well, you know, we'd be running more passes and then taking an average of like 3 or 4 or something bigger than 2, but at least it's not 1. And I have Task Manager open so that we can see when LinPack actually started running. Though you can also see it from core temp. The other reason is like LinPack has a tendency to crash when it hits the memory, like once it loads up the full data set into the memory. So having Task Manager open is a good way of like keeping track of if like what part of the test it crashed at. Anyway, so this should just take a couple seconds. And we're also gonna, you know, test it when we overclock it. Though I don't think it's necessarily going to go much faster than the current frequency. We're going to go in steps of 133 megahertz just because the 133 memory ratios tend to be the most stable. So, you know, so that's basically going from 3200. That would be, I think 3200. Yeah, 3200, 3333, which is a weird one because there's not really anything that like is limited to 3333. It like either doesn't do 3333 or you can go more. Anyway, so you go 3200, 3333, 3466, 3600, 3733, 3866, 4000, 4133, 4266, 4400, 4533, 4600 and 4800. Yeah, 4800 as well. It's kind of weird how it skips. Oh, no, because, yeah. Yeah, it kind of just skips to 4800. There must be a ratio I'm forgetting. Oh, 4666. Yeah, okay. Anyway, so we've got our result. The result is 578 gigaflops on average. So we're going to write that down as our SRB die, which the thing is, I've actually tested this ahead of time. The 32 gig kit, like the single rank 32 gigs is gonna do the same thing. Because it's not a memory, like the data set is 6 gigs. Having more memory isn't gonna change the performance because all of it fits in the RAM. Right, like the only time you see a performance benefit from having more memory is if if you run out of RAM and the operating system has to start stuffing stuff into the page file, because the page file is on your SSD or your hard drive, and it's really, really slow compared to your main memory. So, yeah, that's kind of when, you know, RAM capacity actually starts mattering, but otherwise it doesn't do anything for performance. So this is going to be a long one, as you can probably tell at this point, because we are going to be walking up the frequencies. Because I don't, like, even if I knew ahead of time where it is probably going to crash, I can't guarantee that it will. Because crashing is unfortunately somewhat random. Alright, capture card. And this is going to suck. If this video ends up being less than an hour, I'll be impressed. I'm not setting that as a goal for myself. I'm just saying, like, I have low expectations for this going well. There we go. Like, it's kind of glitchy with the AMD cards, but it's way, way worse on the 1030. And actually, even the GT 710 does this. We're going to do 2 passes again. Yes, yes, no. And hopefully it doesn't crash as soon as it... Well, actually, for me, it would be ideal if it crashed right as it loaded up all the memory, but it's not supposed to do that. Because that would save us some time, because I could just write it off as unstable and we could move on to the next configuration. It unfortunately looks like 4533 in single rank is going to be just fine. Now, the reason why I'm using LinPack and not some other workload that would be maybe quicker, maybe lighter, is because LinPack is actually really sensitive to just about everything in terms of memory settings. So, like, you know, changing your timings has a pretty big performance effect on LinPack. Frequency has a big effect on LinPack. Ranks have a big effect on LinPack. Whereas there's other benchmarks which, like IDA especially, like doesn't necessarily benefit that much from certain timings. Then Geekbench just loves frequency for no apparent reason. It's just like more clock speed, more better, even if in actual real world workloads it ends up not being that much better. Like Geekbench is going to be like, oh my god, it's clocked 200 megahertz higher, therefore it gets like way more points. So Geekbench exaggerates frequency advantages that don't really actually show up in any actual workloads. And then IDA sort of glosses over timing problems Whereas Linpack, in my experience, just about complains about everything. Anything is wrong with your memory timings or your frequency or how many ranks you have, Linpack is going to notice and reward you with less gigaflops. So right now we got a 584. And let's crank it up to 4600. Actually, no, 4666. Yeah, we're going to go in 133 increments or we'll be here all day. I'm not sure if this board will, like, I'm not sure that it'll do 4666 though. Like, this is B-die. It's kind of like, and this is a 4-DIMM motherboard, so like the new BIOS has me impressed. So let's see if if I get to stay impressed. Like this latest BIOS for the Unify is really very capable. Very, very capable. Yeah, okay, so it still trains. So this might even boot 4800 at these settings, which would be pretty neat. It's not going to run Linpack at 4800. Like, it shouldn't run Linpack at 4800. But, you know, who knows? Maybe MSI did some kind of magic. Well, I mean, they got 4400 dual rank working, so they've obviously worked some kind of magic. There we go. Get core temp open. I mean, at this point, I don't really need to open core temp. Like, we can see it's not overheating. It's not like it's going to start overheating after a restart. And it didn't lock up. Surprising. So normally, right as it, you know, hits that 7.1 gigabytes out of 16 gigs, that's when it'll lock up. Assume, like, if you have major memory instability, it'll lock up right then. If you have minor instability, it'll just lock up later in the test or produce incorrect results. I know for a fact it doesn't boot at 4933, or at least it didn't when I was pre-testing for the video, so it would be pretty awkward if it started working at 4933. Okay, so the workload just finished. And the result is an average of 600. Which is actually still pretty slow. Which I'm happy about. Like, so far the test is going as predicted. Or the demonstration is going as predicted, so that's good. Not gone off script yet. So now let's see if 4800 boots. Now 4800 running Linpack shouldn't work because this CPU, like this CPU complains about running 4800 in general. So, like, MSI would have had to have done something absolutely insane to get 4800 working in Linpack with a BIOS update. Or at least historically, this CPU has complained about 4800 in general. I saw a 55 on the postcode, so I think the memory controller is already very upset about something. Yeah, I don't think this is, considering it actually 55'd on the postcode. Ah, there we go, yeah. So 4800 doesn't even work. Doesn't even boot. So that's kind of, so that's the single rank Samsung B-die setup done, right? We can go up to 4666 and it spits out 600 gigaflops, but 4800 doesn't even post. I think 4700 would probably boot, but it's not going to perform significantly different from 4666 because, well, you know, like the difference between 4700 and 4666 is 33 megahertz, which just doesn't really do much. So, yeah, that's the B-die. Let's move on to the Micron Rev B. So I'm just going to shut this down, which that stuff is actually going to boot 4800, but I'll be very surprised if we can run anything. So, let's pull the Vipers out. So, there we go, and I guess I'll show you how you can sort of tell, at least for consumer memory sticks, the thing that gives them away as single rank is the organization of memory chips on the stick. So let me just get the camera to focus on the stick. Come on, how hard is this? There we go, and you can see the memory. Well, okay, no, you can't see the memory chips because there are capacitors in the way. Actually, I have a better idea. Look, I have one that doesn't have the heat spreaders on it, right? So there you can see the memory chips on this side, and on the other side, well, I still have the heat spreader, but there's no memory chips on the other side. Like, okay, I'll have to refocus the camera again. And you can see there's just sort of, well, there's not. I did not plan this out very well. But there, now you can sort of see the foam pad that's under the heat spreader. Well, honestly, the backside isn't so much a heat spreader as a vanity plate because there is literally like a double-sided tape that's like foam. Like it's if anything, it's thermal insulation. So anyway, yeah, these are single-sided, and that's a pretty much a guarantee that it's going to be single rank. At least for I've never heard of a consumer memory stick that would be 2 ranks on one side of the PCB. So yeah, if that exists, then I've never heard of it. Anyway, let's move on to the also single rank Crucial memory sticks. Wait, are they? Yeah, they are. Crucial just has foam that looks like memory chips. I mean, we'll know that they're single rank when you see the Linpack performance, so don't have to be too worried about that. Technically speaking, you can also check, like, if you already have memory sticks installed in your system, then you can check how many memory ranks they have with CPU-Z. But the thing with that is like, I think the thing is, like, checking how many ranks your memory has after you've already paid for it is kind of counterproductive, in my opinion. Like, at that point, it's a little bit too late to be worrying about what it is you actually paid for, right? Like, so the board's going to give us a nice warning that it detected a memory change. Yeah, perfect. And we're going to drop down to 4666 because I don't believe 4800 is going to run. But since 4666 ran on the B-die, which I'm actually impressed by, I wasn't expecting it to finish. Let's run 4666 on the Micron Rev B. And so these are 16 gig DIMMs, right? So that's the thing. And that's kind of the main issue right now with recommending like 16 gigabyte memory sticks for like system builds is, well, you can get single rank 16 gig DIMMs. And the performance between like single rank 16 gig DIMMs and dual rank 16 gig DIMMs is like the way they behave is very different. Okay, so looks like I'm going to have to train it, which just means we have to boot it at a lower frequency first. Because this should work. Yeah, all the settings are correct for that. Okay, so that worked. We're not gonna run LinPack at 4400. There's no point. Or there should be no point. Trying to save time here. And if I'm wrong, then I've just increased how much time we need to spend. It's the beauty of shortcuts that you're not sure about. So you take it, then you get lost, and you've actually lost time. And it gets stuck on 60 again. What the hell? Like, I don't even know what 60 means. I've not seen that one before. And is it gonna just give us a memory error again? Okay, no, now it trained. Okay. So this is gonna be, like, considering how much it didn't want to boot, now I'm concerned that it's gonna be extremely stable. Oops. Wrong test. Damn it. 2, 3, 2. I normally use the 8 gig test for, like, stability testing, so it's kind of like habit is to autopilot into pressing 4. And it's still running, so that's a pretty good sign. Ah. Okay. Not stable. At all. So that's very upset right there. But you can see we have 32 gigs of memory in Windows. Just gonna restart, and I guess we'll just run it at like 4533. I don't think I'll have to go all the way down to 4400. Though I do want to show something with these DIMMs just for the sake of demonstrating. So we know 4666 isn't stable, but I did want to show that as far as the single rank setups go for bootable memory settings, this right here should work. Please. I believe in you, motherboard. $60 is not a valid error code. Because I think it's getting like stuck on GPU initialization, which is just kind of like, well, if it's kind of unstable, yeah, that's probably where it's going to get stuck. And yeah, so 4800 boots. 4933 does not work at all. You can already see that it's very upset about trying to boot even 4800, like 4666. So I don't see value in going up to an even higher frequency. But the point is, single rank, you can still boot 4800 megahertz, and this is with 1.5 volt system agent voltage. Well, I guess that explains why I booted 4800 at all. It was supposed to be a 1.45, but I guess like I forgot to change the voltage after testing. I think I was trying to get 4933 working. So that's just a leftover of that. Don't daily 1.5 volt system agent. Or at least I wouldn't daily 1.5 volt system agent. I wouldn't go over 1.4 volts on that. And the capture card is not cooperating again. Lovely. I wish there was some way I could like force it to like redetect whatever's connected to it from OBS. Because currently what I have to do is I have to unplug the HDMI cable and plug it back in, which is super not fun. The main point here is just to get a, like, maybe I should have run it at 4400, just to show that the two single rank setups, regardless of actual memory capacity, perform the same. Right? But, Well, let's hope this time it doesn't crash. I don't really have any other 16 gigabyte single rank DIMMs, so I needed to use these for this. So that's a 590. The previous setup at 4533 was doing 584. So that's the thing, is that there's going to be some variance because we're only taking an average of 2 runs instead of an average of like 20 runs or something. But this should be pretty close. The main point is, like, there's not a performance difference for the raw capacity. Then we're going to switch to 32 gigs, but on dual rank DIMMs. And that's going to clock way worse. But it is going to be faster. Actually, significantly faster. Well, yeah, it's going to be outside a margin of error. And our second result is 500. Right, so it averages out to 593, which is actually faster than the B-die setup was. But again, it's just like we're not running enough tests. Because the thing is, normally the first test is a little bit slow, and then the second test is like significantly faster, and so it's just like... And then consecutive tests tend to stay closer to the second test in terms of scores instead of the first test, so... Yeah, running two... Like, taking an average of 2 results is not ideal for getting the results super close together. But anyway, that was 593. Like, it's going to get blown away by the dual rank setups anyway, so that doesn't matter. So we're just going to reset, which hopefully Windows doesn't get upset about me doing that. It's going to be like, there's something wrong with your computer. Trying to diagnose problem. No, the problem's me. I am very much the problem. There's nothing to diagnose in the system. Anyway, we're going to drop all the way down to 4400. I'm just going to save. And then we're going to power down, and I'm going to swap in some 16 gig Samsung B-die DIMMs, which are dual rank, because Samsung B-die is an 8 gigabit memory chip. So we're just going to shut down. So we've just gone... So the first setup was 2 sticks of Viper Steel. Now we've done 2 sticks of Ballistics Max. They perform basically the same. This actually has stability issues. Like, it's kind of weird how it boots higher frequencies, but is not stable at low... Like, it needs to be clocked a bit lower to be actually stable. But I think it's just the timings. Like, I think the timings are more dialed in for B-die just because that's what I normally work with. And I just kind of tried to adapt them a bit more to get this to work. And obviously that was a suboptimal way of doing things based on the fact that it was crashing at 4666. Anyway, here we have dual rank B-die DIMMs, and the way you can... Actually, on these you can see the memory chips, if I could get the camera to focus on it. Come on. There we go. You can see the memory chips on this side and the memory chips on that side. Dual rank DIMM. Oops. I'm very coordinated. Well, part of it is that I'm not looking where I'm putting stuff, so... That's one. Also, fun fact, these are 3200 CL16 sticks. And yeah, I'm just going to run them at 4400 CL18. Corsair bin's really loose. Okay, well, now the motherboard's upset again. Very upset. I guess I'll have to walk it up from 4266. So we'll have to drop the frequency a bit and then climb back up. Which is fine. Or I might have not seated the DIMMs fully. I've run into that issue. I think I haven't seated them. Yeah, it's just stuck on 55, so I've not seated one of them. And there we go. Okay, so I don't have to do anything. Or do I? Okay, yeah, CPU memory changed. And this should just work at 4400. And it does. That's assuming we actually get LinPack scores, but it really should get LinPack scores. And then we're gonna, like, the last configuration is we're gonna run four sticks of the Patriot Viper Steel. So, which is gonna score this, like, in theory, it should score exactly the same as this setup right now. Mostly because I've actually, like, manually set all the timings. Because if you leave it on auto, the motherboard can sometimes do things for, like, compatibility reasons for various memory sticks, and yeah, I didn't have to close that, did I? But yeah, like, the motherboard will sometimes do, like, various optimization for stability based on which memory sticks you have, and a lot of that is just, like, changing the subtimings, and, like, that can skew the performance testing. And the main point of this is to show you, like, single rank versus dual rank running the same settings. Like, in reality, they don't behave the same in terms of overclocking. So, like, right now we're at 4400 on this dual rank setup, which is actually really high. I mean, it's not the highest, but, like, on, say, Z390 with these DIMMs, on the vast majority of motherboards, you can forget about going over 4000. So, yeah, that's the thing. And in fact, before I updated the BIOS on this board, these would top out at like 4200. So, yeah, and right off the bat, you know, first score 625 gigaflops. So, absolutely demolishing both of the single rank results, even though we're running 266 megahertz slower than the single rank B-die configuration. Right, and we're beating that by 25 gigaflops. Now, admittedly, we're still waiting for the second score for the average, but it's not going to go down from here. Or at least it really shouldn't go down from here. It should only go up. And again, you know, in Task Manager, we have 32 gigs. So this is 32 gigs, same timings, worse frequency, better performance, because dual rank. And the second result is 631, so the average is a 628. So yeah, 4400 megahertz. And the thing is, at 4400, right, you can run tighter timings than at like 4666. So I'm leaving performance on the table here with the settings that I have in the BIOS, because the settings in the BIOS aren't actually set, like the timings that I have set in the BIOS aren't meant for peak performance. They're meant for demo purposes where I can run the exact same settings across 4 different memory configurations, which is not a great way of setting your timings. Like, that is generally, like, you would want to tune the timings to the limits of each memory configuration individually, but then we'd be here all day, and I don't feel like doing that. And then also, like, stability starts factoring in, and honestly, even this might not be completely, like, this is probably not completely stable. Like, 6 gigs of LinPack is not a stress test, especially when you only do 2 loops. Anyway, that's a 628 for dual rank on, you know, 4400. So now we're going to see if it'll overclock. It might boot 4533, but it's not going to go above that. And I know that because I've tried that. Honestly, even 4533 is a struggle, and if like, it's not going to run... I shouldn't say it's not going to run LinPack, but I'll be very surprised if it does. There we go. is going to go up to 4533. And it's 55ing. So when it spits out 55, that's like memory controller, yeah, complaining about settings. It's very upset with me. Very, very upset. I don't think, yeah, it's not. I think we just hit the auto recovery at this point. We're going to get an overclocking failed message. Aren't we? Yeah, so overclocking fail. So 4533 doesn't even boot. I mean, I'm pretty sure I could coax it into turning on, but that's not the point, right? Like, you can immediately see that there's a bit of a... Oh, like, we've lost some overclocking headroom by just different... You know, still same capacity, but dual rank. So we've lost overclocking headroom. Anyway, so I'll shut this down. And now we will load up 4 memory sticks of the Patriot Viper Steels, which are all individually single rank memory sticks, right? But from the you have to look at it from the perspective, like, so memory sticks come with ranks of memory on them, right? And from the perspective of the memory controller, it doesn't matter how like where the ranks are. It's kind of like you can buy like you could buy it's kind of like having a box with 2 apples in it or 2 boxes with 1 apple each. You still have 2 apples. It doesn't really matter that they come in different packaging, right? But it's still also fair to say, like, you can have a dual rank DIMM, and then the memory controller is going to run your memory configuration in dual rank, or like you have single rank for, you know, you have single rank DIMMs, and when you have 1 in each memory channel, the memory controller. Because the other thing is actually the ranks are per memory channel. So it's not like this is a... I'm putting 1 rank on one of the 2 memory channels that the CPU has, putting another rank on the other channel. So right now, this is single rank, dual channel. Then we add another rank of memory to channel 1, and now that channel is in dual rank. And at this point, you're probably wondering, so what would happen if you took those dual rank DIMMs and mixed them with the single rank DIMMs? Would you get triple rank? And the answer to that is yes. Is it a good idea? Not really, because the PCB differences between the DIMMs lead to some annoying, like, compatibility issues when overclocking, and just generally weird behavior. But technically speaking, triple rank is a thing. But the only reason you would ever want to run it is if for some reason you want 48 gigs of RAM, but like 64 is too much. Or I guess if you just have a bunch of cheap mismatched RAM lying around, right? Like that's the other option for running that. So anyway, so now we're in dual rank with 4 single rank memory sticks, because the CPU has 2 memory channels, right? So each memory channel is the person actually getting the boxes of apples, if we go back to my apples in boxes analogy. And this should still run 4400. I'm not sure if it'll do 4533. I really doubt it. But I've not tested the 4 memory stick setup at all. And also there is, of course, quad rank when you take 2 dual rank sticks and shove them into 1 channel together as well. Why is it 55ing? There's a bit of a chance that there's like a contact issue with the memory sticks. Or technically this board is a daisy chain, but on a previous BIOS version, 4400 would work. Okay, well, it looks like the frequency's gone down. So I guess I might have to run 4266, or we can try training it, I guess. And that runs perfect. I mean, I guess I could also run a 4266 dual rank test to just show you how much, like, dual rank matters in terms of performance. Because considering the fact that the 4400 setup was getting 628 gigaflops, actually gigaflops, the S at the end of flops is seconds, so I was about to say gigaflops per second, which is super redundant, and then I said it anyway. No, but the thing is, like, considering the 4400 setup was getting 628 Linpack points, I will now refer to it as Linpack points. Yeah, so that was getting 628 Linpack points. At 4266, I would assume we should be getting like 615 Linpack points, something like that. So still well above any of the single rank configurations, which topped out at 600. Well above. Above. Like... And 2, yes, no. Like, that's the main thing is, like, yeah, so, you know, this suboptimal memory setup is still faster than running, one single rank at 4666. Or at least I expect it to be faster. Also, if you dial this in, you can get this, like, the dual rank B-die setups, you can easily get them to around, like, 660 gigaflops. So, yeah, they can go really fast. And maybe if you had a really strong CPU, you could get them all the way up to, like, 700. But my CPU does, like, getting my CPU to do 660 stable is a challenge. Oh, so we're getting 623. Yeah, so basically, single rank is just getting obliterated here, right? Like, it's not even a contest. The first result is 623. And the test is over. And the second result is 603. Oh, so the average ended up being 613, which was actually kind of what I was thinking the average would end up being. Funny that the second run scored so much worse, though. It's weird. That shouldn't really happen. Normally, the second run should always be faster. Anyway, so that was at 4266, and still, you know, faster than a 4666 single rank setup running the same timings, right? Like, technically speaking, like the 4666 setup was still running the same 18, 22, 22, 700 TRFC, you know, same sub timings. And the thing is, all of your memory timings are actually measured in clock cycles. So CL18 at 4666 is actually significantly lower latency than CL18 at 4266. Or TRCD22 at 4266. It's like that's slower than TRCD22 at 4666. Significantly so. But yeah, the thing is, this is dual rank. And dual rank just kind of doesn't care if the timings are bad. The only downside is like your overclocking range goes way down. So let's see if the board will... Like, the thing is, sometimes booting straight to a high frequency doesn't work, so you might have to, like, boot a lower frequency first, and then you can boot the higher frequency, but apparently no, it's just not going to do 4400, I think. Yeah, it's just not going to do it. Cool. Well, that, you know, that's actually kind of the point of the demonstration. So we went through, what, 4 different memory configurations, right, from 16 gigs all the way running, like, 4666 CL18, and producing... 600 gigaflops to 32 gigs, also still single rank, producing 595 gigaflops to 32 gigs producing 628 gigaflops, and 32 gigs producing 613 gigaflops. All at the same timings and just very different frequencies the entire time. And that's hopefully, like, this is like the whole point of this video is to be a practical demonstration of memory ranks, because I've done plenty of videos where, like, I've explained them in the past, and I guess it just doesn't come across if you don't, see it in the real world with tests and, like, how it actually impacts the overclocking and how it impacts the frequency and the stability and the performance, right? So that's the point of this video. We didn't do quad rank and we didn't do triple rank because I hate both of those. Triple rank is just awful. In, like, I've worked with it in the past for fun, because as soon as I had the ability to do a triple rank setup, I was like, I wonder how many problems this is gonna have. A lot. It's just problems. And quad rank is just not fun in general. I'll just put it that way. I don't like quad rank. Quad rank is for people who, like, the only reason I can see to run quad rank is if you need more than, like, 64 gigs of RAM, which, if you need more than 64 gigs of, like, the other issue with that is, like, you're going to be stability testing your memory for, like, a day. Well, yeah, multiple days at a time, like, because it just takes so long to test that much memory. So anyway, we have this dual rank setup right here, right? Because we've got one rank on each memory stick, and the memory controller sees this as dual rank, because each channel has 2 ranks assigned to it, so it can interleave them. Dual rank memory configuration using single rank memory sticks. And then, of course, we have the dual rank setup with the dual rank sticks, and then the 2 single rank setups with the single rank sticks, but in different capacities. And that's the other thing is, like, again, with the 16 gig DIMMs, especially right now, if you're going to be buying, like, cheap 16 gig DIMMs, going like, oh, I'm going to have great performance per clock, which actually is really useful, right? Like, one of the easiest ways to get a bunch of extra memory performance without buying higher spec memory is to just get more ranks of memory, because if you run, like, dual rank 3200 CL16, it actually performs pretty well. It's, like, on par with, I think, around 3600 single rank. I have a video doing a bunch of single rank XMP versus dual rank XMP setting testing. You should go check that out. I'll hopefully remember to leave a link in the description to that video. Yeah, that video, like, that's the thing is, like, so you might be like, oh, I'm going to buy some cheap 16 gig 3200 CL16 sticks. They're going to be dual rank. I'm going to get, the dual rank performance benefits. Problem is, as of, like, somewhat recently, because if you did this last year or even the beginning of this year and you bought 16 gig DIMMs, you were pretty much guaranteed dual rank, because 16 gigabit memory chips were just starting production and they were very, very expensive. So you wouldn't get them on, like, 16 gig DIMMs because the chips were in high demand for, like, 32 gig DIMMs and server DIMMs. And there was no reason to make 16 gig consumer memory sticks with expensive 16 gigabit memory chips in single rank. But now 16 gigabit memory chips are very common. And so it makes, like, having memory chips on just one side of the memory stick is cheaper than having memory chips on both sides of the memory stick. It simplifies the manufacturing process. You can also just factor in the fact that now there's half as many big BGA components, right? Like, it simplifies the manufacturing process. So single rank 16 gigs right now is actually, it might depend kind of on the brand as well, but it should generally be starting to be getting cheaper. So if you're thinking of, like, picking up a 16 gig DIMM to get dual rank, it's probably not going to work now. If you did it last year, it would have worked just fine. But yeah, now you have DIMMs like these, which are, 16 gig, and these are 4000 megahertz. I don't think Crucial ever made them in a dual rank configuration, and we're not going to keep running the system. I'm just putting them here for, oh, whatever. I shouldn't have bothered. I should have just put them this way. But yeah, the thing is, these are 4000 CL18, so, like, I don't think Crucial ever made them in a dual rank configuration, because the spec on them is kind of difficult to run in dual rank. It's not impossible, it's just difficult. or at least on Z390, it was really, really difficult to run, dual rank at that kind of frequency. Um, and so, yeah, so now it's like the 16 gig DIMMs aren't guaranteed dual rank. 16 gig DIMMs are 16 gig DIMMs, and some of them are dual rank if they have the correct specs and the correct memory chips. I'd assume most of the cheap ones are now transitioning to single rank. Um, and then with the other sticks, right? So we have our two single rank sticks over there in the different capacities. Then of course we have the 16 gig dual rank Vengeance sticks. So yeah, that's it for the video. Hopefully that cleared some questions up for people. Not sure. And yeah, so if you like the video, then there's a like button. I'll just do the usual outro. Screw it. That's what I get for being creative. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with the channel, I have a Patreon. There's a link to that down in the description below. You can support me directly through that. And then there's also the AHOC Teespring store where you can pick up shirts, stickers, posters, shirts, posters, the usual YouTuber merch. And there's a link to that down in the description below as well. It also helps out immensely with running the channel. Yeah, that's it for the video. So thanks for watching and goodbye.